Hello, welcome back. Okay, welcome back everyone. So for the first presentation after lunch about practice and prospect of 5G and 5.5G smart flexible manufacturing, I'd like to invite Mr. Jimmy Gu, Vice President of Schneider Electric China Supply Chain Performance and Digitization Project. Mr. Gu.
Okay. Good afternoon, everyone. Let me introduce myself. My name is Jimmy from Schneider Electric, and thanks to Huawei's invitation, it's my honor to be here with you. I noticed that very few end users is present here, so I'm very honored to be the representative of the end users in the industrial business. So, first of all, let me introduce a little bit about my company. Schneider Electric is a global player and is a global expert in the domains of energy management and industrial automation. So 34 billion euros sales, and this year we will have about 15 to 18% of growth. So we have a lot of digital offers. First, we use a lot of digital solutions to renovate and improve our own operations. And second, we also export these digital services and solutions to our customers to help our customers improve their efficiency in operations, as well as to reduce carbon footprint and emission to get greener in the production and to support the sustainable development with this leverage of smart and green technologies. So look at the supply chain, because I'm in charge of the supply chain in China for the digitalization and also the performance improvement. So in China, we have 18 smart factories and DCs, distribution centers, according to the global standard of Schneider Electric. And we have one lighthouse factory defined by WEF. And for the ranking, according to the Gartner Global Supply Chain Ranking, we rank #1 in this year. Yeah. So we leverage, as I said, we leverage our own solutions to realize digital transformation and the carbon reduction. So like at the bottom, you can see a lot of connected products, okay, and then to extract and acquire a lot of data from the operations. And in the middle, we have the edge control to monitor and to do the real-time monitoring and the supervision. And at the top is smart services and applications based on BI and AI technologies like that. So we have our own smart transformation and smart operations strategy, okay, defined. So according to this strategy, we have a lot of domains where we want to leverage the smart and digital technologies to combine with our business processes for the biggest synergies and values out of it as a result. So in this process, we find a lot of opportunities where we can, really integrate the 5G technologies as an enabling technologies to enable a lot of use cases and value delivery, okay, where we cannot deliver the values with the previous Wi-Fi technology, for example. So I listed something here on the right. We want to do the digital twin of our factory and DC's operations. So we need to have a lot of widespread and ubiquitous sensing of our operations, okay, from everywhere. So we needed a massive connection capability of the 5G and doing a lot of data extractions, acquisitions with our IoT foundation. As well as on the market, we are facing fierce competition, and it's becoming more and more segmented or segment-oriented. So the lot size is reducing significantly in the coming years and in these previous years also. So we need to make our production lines more and more flexible and agile, able to quickly adapt to the customer demand fluctuation. Okay, so when we design the lines, we need to consider if the product is dropping, if the demand is not that good, what else products we can produce on the same line to maximize the capex investment. So make these lines flexible as possible. And also we have a lot of AI applications for the quality visual detection. We use a lot of AIs to replace the human beings for the final quality inspection and process inspection for sure. So for this AI visualization project solution, in the past we used a lot of decentralized solutions where we needed the servers close to the product line, and this cost a lot of money and also a lot of efforts in the maintenance. So in the past years, we have centralized our AI platform and using the 5G to do the image extraction and also send back the signals and the controlling signals to the lines. For supply chain collaboration, we need to monitor some critical assets that we outsource to our suppliers. So from the upstream suppliers, we need to get these data and images through the 5G slicing capability and to do the really real-time monitoring to ensure the upstream capabilities, the upstream performance is there. And for the logistics, of course, it's a mobile application where it's a perfect match for the 5G. In the past, we used Wi-Fi. It's really unstable, unreliable, okay? And so we have a lot of AGVs and AMR moving around within the plant, and more and more, okay? So do the good fleet management, we need a very reliable wireless network to support us to do that. So some cases for your information. By the way, we are working with China Unicom and Huawei. So our solution is like really the private 5G network, which is taken down to each site of our Schneider company. So we have like 14, 15 sites equipped with these private networks of 5G in China. So it's like this, what I said, it's in this massive connection of all the assets. So with the 5G, we can use the wireless solution. In the past, we used the wired solution with this hardware IoT box to do the extraction, and it's not convenient and it's complicated. It's not good for the maintenance also. So now we are just remove the hardware and put everything on the MEC and use the software to extract the data from the lines. And here we do the predictive maintenance of our laser machines to detect the early signals and then to give the interference in the very early stage when it does not turn very seriously mistakes. And this is what I said, the flexibility of the lines. The production lines cannot be as rigid as before. You need to quickly adapt to the different references. Even product families are different also. We can adapt to the ups and downs of the customer demands. So you can see, of course, it's not only 5G. Okay, it's a combined solution of many technologies, including 5G for the network. But also there are some other mechanical design, electrical design, very flexible design solutions coming together. But 5G plays a big role here, okay, to enable us to move around all these stations quickly and to build another line, okay, and yeah, to have different combinations. So we save a lot of PLC because this PLC is centralized in the server room. So one PLC to control the several stations. In the past, each station we have dedicated PLC. It's a waste of the resource of PLC, and also it's not good for the maintenance, because if you are working in an environment which is not that user-friendly, so the maintenance of the PLC will be an issue. But with this centralized deployment, you just can do the maintenance very easily in your server room. Okay. Of course, we're using the 5G LAN and the QoS to reach this flexibility and also the high performance. Yeah, this is what I said, the AI vision. In the past, we're using the server close to the line to do the inference of the AI model. And then we cancel all these servers, and we just bring together to the MEC, okay? And then using the MEC computing power to do the inference, and then send back the result to the line. But the key here is that we need a good uplink capability to send the images up to the MEC and do the inference, and then send back the result. So with the 5G, now this kind of solution has become a kind of a new standard for in the future model deployment like that. We have in more than 10 plants have these AI visions applications, and covering more than 100 lines. So for the AMR, it's mobile fleet management. Of course, it's not only the AMRs, but also some cameras and POCs, scanners. All these signals are extracted and acquired and sent to the MEC through the 5G network. And then we have this controlling system deployed on the MEC with some AI model behind to navigate, okay, all these AMRs, which might from different vendors. Okay, it may not be only one brand, but several brands together, but no problem to do the navigation and the control of the fleet management. So with the comparison of Wi-Fi and 5G, you can see that the stability, performance is quite different. In the past, we used Wi-Fi, but when the number of the AMRs going up to more than 5 or 6 in the same workshop, and also between the workshop and the warehouse, the Wi-Fi becomes quite unstable. You can see the fluctuation, but now with the 5G, it has been deployed for more than 1 year. So in these plants, the performance quite stable. And so we are putting more and more AMRs into the factory. Also, with the increase of the number, the 5G will play even a big role and show the strengths. So here's the pipeline. As I said, that for all the cases, we will do the first pilot case from 0 to 1. And when it gets mature and when it proves its value, then we will roll it out from 1 to n across the sites. So you can see these cases in blue. It means it has been proven valuable to the industrial business and to the discrete manufacturing sector. So we are rolling out right now across all the sites in China of Schneider Electric, all these blue cases. And for these cases in the orange, this is the pilot case that we are working on this year. And I firmly believe that some of them will be rolling out next year. So this pipeline will continuously be enriched when we dive into these synergy areas between 5G and our manufacturing operations and the supply chain management. Okay, so last but not least is some expectations on the 5G and the 5.5G. While we are using the 5G, we are actually exploring the boundary of 5G application in the industrial scenarios. So we see some strengths, but also we see some limitations. So for the next generation of the 5.5G, we have some expectations from our perspective. First of all, we have a lot of different, wireless networks inside the plant. Due to some legacy issues, we have the Bluetooth, we have the Zigbee, we have the MB, we have also the UWB, all these kind of different wireless networks inside the plan, which makes it quite complicated. Okay, so we really hope that 5G, one network, can do all the convergence and integration of all these wireless networks together, so can integrate well and with MB, with the passive IoT, with this positioning system, and enable us to use 5G one network to cover all these scenarios. Okay, and also the other part is the cost. For sure, it's one of the biggest concerns from our users. So we expect that for most of the industrial scenarios, we don't need these actually high-speed connection or high capability in the bandwidth. We only need to acquire some data from lines. So maybe we only need this reduced capability of the 5G, and hope that the ecosystem of the 5G terminals can be more mature. We can have more options on the market, more choices to choose some cost-efficient products, and also to reduce the price of the 5G model. Okay, and most importantly, that when we are in a business environment, we cannot use the 2C solution to directly copy to the 2B. Okay, like what I said, the uplink. The uplink is more important for the 2B, all right, than the downlink. So the uplink, we need to upload a lot of videos and the high definition pictures. So it has to provide this kind of uplink capability. Yeah, so that's all from my experience. Thank you for listening. Thank you.
Thank you so much. And that last point was really important in terms of uplink. Thank you.
Thank you, thank you.
Okay, so for the next presenter, please, Alex Besson, founder and CEO of the Besson Group.
Welcome, everybody. As Richard said, I'm the founder and the CEO of the Besson Group, visiting from the United States here. And I'd like to thank Informa for the invitation to present our private 5G network case study regarding the Cleveland Clinic Hospital in Ohio, jointly launched with Verizon wireless business just a couple of months ago. So what I'm going to cover today is looking at the private 5G market overview, and then looking at some of the use cases in healthcare, and then talk about our case study, and then and also focus on the business case, which is one of our key expertise on coming to private networks, and then and give a brief background on our company and what kind of services we offer for private networks. So first, I would like to talk about the definition, because private 5G, can be different meaning to different enterprises or the individuals. So the way we define it are dedicated networks for consumers, businesses, and Internet of Things. And private networks can be based on licensed, shared spectrum, or unlicensed spectrum. Depending on the country where you're coming from, or even in Turkey, they can be deployed in the different spectrum bands, right? So we estimate that the private 5G networks, globally is going to be another component on the growth rate around 42% between 2023 to 2027. And also the availability of the commercial 5G standalone network, right? As well as additional licensed, shared, and unlicensed spectrum bands will be available, again, depending on each country. So we estimate that the serviceable addressable market for the private 5G network is about $3.3 billion in 2027, right? We also have the total addressable market, which is a TAM, but when we do our estimates or the forecast, we prefer to focus on the SAM, I think, which is much more market realistic. In terms of the business models now, there are a few business models out there. So we're going to look at the 4 different models today. The first one is a standalone private 5G network for IoT devices only. Right? So this is a closed network. So that means that the devices, they won't operate outside the private 5G network. Right? The key drivers for this is about the cost, security, coverage, and capacity. Right? So the next is a standalone network for smartphones. So again, it's a closed network. The smartphones, they will be able to communicate on and off the private network, but they're not able to roam onto the macro network. Okay? So some of the key drivers again here: cost, control, security, and coverage. Right? The third one we refer as open network for smartphones, which is like a neutral host network, or DAS, distributed antenna system type of a network. So they be able to, I would say, communicate with the outside world. It's an open and a hybrid network, right? So here are the key drivers, looking at the capacity, coverage, and being able to function as a hybrid type of a network. The last one is a standalone network with outbound roaming for smartphones. So in the US, we have it. Most of the top 3 operators, they are utilizing, looking at this standalone network. Not just a closed network, but they have an option to have a hybrid, to a macro network. Some of the devices be able to communicate. So in terms of the market survey they have done this summer in the US, they look at the spectrum bands for the private networks. So the survey was, when considering the private cellular networks, what is your preferred strategy for procuring the spectrum? If you see it, 31% of the respondents from the enterprises, they prefer to license the spectrum directly from the mobile network operator. So again, some countries, they got the spectrum, from the current regulatory, for acquiring the telecommunication authority, but maybe they're not able to do that. So the only choice for them is to, sign an agreement with the mobile network operator and license spectrum from that. So in the US, we do have a shared spectrum as well. That was licensed a couple of years ago. It is a bit unique in terms of the arrangement with the government and the enterprise or the license holders. But the respondents, they still preferred to license the spectrum directly from the mobile network operators. That's a good thing to keep in mind for the private networks, right? The spectrum is the ultimate, I would say, criteria selecting what private network you're going to deploy based on the use cases, then select the spectrum accordingly, because some spectrum might not be suitable for the healthcare use case, for example, right? Or manufacturing use case. So it's very important to identify the spectrum requirements for the use case. So let's look at use cases on the healthcare today. So we have, we came up with 6 use cases. Remote surgery, that includes the applications like robotic surgery, image file transfer, medical devices, in a hospital can be connected to smartphones, smart scales. Looking at the hospital monitoring use case, that includes temperature, lighting control, connected ambulance, right? You have the remote diagnostics, remote communications there, and asset tracking, that include the medical equipment, hospital supplies as part of the applications, and then telehealth, right? So that includes the remote diagnostics and remote monitoring. So for each use case, what we come up with is we done a survey understanding what are the bandwidth requirements for each use case, so that when we consult our clients, we can understand what are the network capacity requirements will be based on the use cases, right? So that's how we drive the business case at the end. So again, as I mentioned to you, this is the press release was done in April of this year to launch the first private 5G network at a hospital in the US. So in terms of the partners, Verizon was the licensed spectrum provider to the hospital, and the KPMG was the system integrator in that partnership. So you are looking at the size of the hospital around 8,847 square meters. So it's about 95,000 square foot in the US. So it's a brand new hospital. So in terms of the spectrum, Verizon allocated the C-band spectrum, which is their own average 161 megahertz. So it's between the 3.7 gigahertz band to 3.97 gigahertz. And then they also allocated millimeter wave band spectrum. So depending on the use cases, they own about 2,054 megahertz of millimeter wave band spectrum nationwide. So each spectrum band allows for different capacities and speeds, and offering different choices depending on the use cases at the hospital. Okay. So the use cases that Verizon was implementing at the hospital included the asset tracking, patient check-in kiosks, enhanced digital display, in-room infotainment for patients, AR/VR adoption for medical staff, education and patient education, and the AR/VR adoption for assisted surgery and imaging. So these are the current use cases that they launched the hospital with. But they will be adding additional use cases after, probably the first initial year. So they launched the private network as a service, right? So they look at the deployment included the small cells on the core network, the site planning, network design, installation, commissioning, and then they look at the application use cases, the application development and integration, network security, and then managed service, right? So the SLA monitoring, network support, performance optimization, and maintenance and logistics. Everything is done by Verizon in this partnership. So let's look at the business case. So what we have done, so we have developed the industry first business case and TCO tools for private networks, private LTE and private 5G networks. So in this example, you are looking at our hospital, the private 5G tool for hospitals. So we look at the hospital sites, can be any hospital around the world, and then we look at the use cases, and we allocated the bandwidth assumption for each use case in order to understand the capacity, and then we select the spectrum, low band, mid band, high band spectrum. So in this Cleveland Clinic example, we selected the mid band spectrum and high band spectrum. C band, which is constant mid band, and millimeter wave band is high band spectrum. And then we calculated the small cells, number of small cells required for this private 5G network, and then the number of devices and the number of bandwidth. That gives us the calculation of a CapEx and OpEx, and at the end, we calculated total cost of ownership for this hospital. The hardest thing I can share with you is calculating the return of investment, which is called the opportunity cost, when you're looking at the private 5G network. It's really, really challenging, because you need to understand what is the key drivers for the use cases for that enterprise to deploy this private 5G network. Not just, hospital, factories, you name it, shipping ports, anything, right? If you're able to calculate opportunity cost, the ROI, everything else is straightforward for us. Right? So what we have done, based on our tool, we came up with 30 mid-band spectrum small cells. We calculated 20 high-band spectrum small cells. So total small cells about 50 for the hospital. We calculated about 635 IoT devices that be connected to the private 5G network. Total bandwidth about 3,800 gigabytes, okay, for the network. So again, this is based on an OpEx model, right, not a CapEx model, because of the managed service cost. So very low CapEx, but a high OpEx, right? So looking at the initial year one to around $347,000 to deploy this network. And then we look at some of the KPIs, in terms of the CapEx percentage, OpEx percentage, CapEx per device, OpEx per device, and then we look at the dollar per square foot. That's the key KPI that you have to keep in mind when you deploy this private 5G network, especially for indoors, right? It's about $3.64. If you look at the Wi-Fi, it's about 70 cents. If you look at LTE, it's about $1. So this is about the, 5G is in a reasonable range. So some information about our company. We established in 2004 in the state of Virginia, just outside Washington, D.C. We offer strategic advisory, business development, market research, and training services. We developed the industry first, again, the business case and TCO tools for private LTE, private 5G, and neutral host networks. So some of the experience on the private networks include agriculture, manufacturing, smart cities, oil platform, and US military bases. So, and the last one, I would say, is TBD. We are talking to a mining company at this time to help them understand the deployment cost of a private network there. So all of these engagements, we were engaged to a mobile network operator or system integrator. And then we offered our strategic advisory and the business case services for them. So thank you for your attention. If you would like more information about the company, please visit the website. Thank you.
Thank you, Alex. Okay, so for the last presentation before the break, can I have, please, Mr. Erhan Eraydin from Head of National Networks Engineering, South Vodafone, Turkey.
Thank you very much. First of all, welcome to Istanbul. So I'm as well from Turkey, Istanbul. I hope you enjoy these 3 days here in Turkey. I think we are in a very beautiful place, very good located, and the weather is also not that bad today. Yesterday it was a little bit raining, but today is much better. So I would like to talk about our Vodafone core network strategy a little bit in this session. So I will talk about the core network evolution and as well the MPN product solutions that we are categorizing. And then I will also touch how we are getting ready for the 5G. So just be clear. So we don't have actually 5G at the moment in Turkey. We have one only commercial site, which is the Istanbul airport. Maybe you have been there during your visit. We have only 5G services for the end customers only in Istanbul airport. For the rest, we don't have any service at the moment. So let me start. I don't want to touch all this beautiful triangle. I think whoever developed this triangle, he should be famous. But I will more talk about the enablers from Vodafone perspective. What do I mean with the enablers? So because this triangle is more talking about the use cases that we are going to give as a service in the 5G, as Vodafone, we would like to talk more about our enablers, how we make this happen. And when we talk about enablers, I think one of the critical things is, for the core network perspective, is the core cloudification. We have started the cloudification journey already with 4G. So 100% of our core network is already cloudified. But now we are going to move to container-based solutions. Of course, to be able to manage this kind of services, we need network slicing. And security and privacy is one of the critical as well enabler. Depending on the service and the use case, we should be able to provide the security requirements. And when we manage this service, of course, orchestration and automation will be much more important. That's why it's also very important for us to have the automation and orchestration running. And we more and more see that the latency or the end-to-end latency is very critical to be able to, perform these real-time use cases. That's why MPN and the MEC will be also very critical, because we need to push the services as much as possible closer to our customers. And of course, to be able to integrate with these kind of services, we need to work with the third parties, we need to work with different providers. And to be able to do that, we need as well the API layer, so to be able to integrate with the third-party services. So these are the 6 enablers that we are more focused on at the moment. So how we are moving forward in our core network. Today, sorry, I jumped one more, yeah. Today we had an evolved packet core, which was already virtualized, but we are moving to actually the single packet core architecture. And in our single packet core architecture, we are talking about service-based architecture. So the integration between different technologies and the interworking will be much more easier. And with this new architecture basis, the communication flow between different nodes and different functions will be much faster. And it will also enable, with the help of the containerized solution, it will be more scalable, more flexible, and as well more future-proof. Even without 5G, we are moving to this single packet core architecture already today. And while doing that, it is also important to mention that we are doing it very fast as well. So within 18 months, we are actually changing our existing architecture to the service-based architecture and make this, even without 5G, the single packet core ready. And another advantage is when 5G comes, it is easier to integrate new 5G nodes on top of this architecture. And as you can see as well from the below, as I said, in 4G, we have already started the virtualization journey, and it's already 100% on the VNF, but we are moving to the CNF and CAS, because we have seen as well the orchestration on the virtualization doesn't work as we have expected. So you need to move to the CAS to be able to benefit more from the orchestration and automation. So this is also one of the key elements that I have discussed, in the beginning as an enabler. To be able to make the automation and orchestration happen, you need to move to the CAS as well. So overall, we are changing the architecture, even we don't have the 5G ready, but it will make it easier our life to enable 5G on top of it. Maybe we don't have the 5G yet, but we are working on the 5G use cases, of course, to be able to learn what kind of requirements each use case has. And we have actually in our Vodafone headquarters, in Maslak office, we are building different use cases to be able to, touch the real use case. And if the broadband capacity is enough, or if we need better latency for that specific use case, or how can we really leverage from the existing capacities of the network. And we have exercised the cloud gaming, we have the XRs, we have the 5G to business demo areas. We are together with Huawei, we are working on the remote crane operations. Another football table, this is maybe more for the consumer, but real time is also another focus there. We have cafe robots, we have chatbots, we have spots, etc. So these are the use cases that we are working. Maybe it's at the moment more on a trial base and it's only in the headquarters, but it's helping us to understand what the technology can bring us. And then we talked about the MPN, and we have seen as well a great presentation as well from Bering Group, and they were more talking, I guess, more the isolated solutions. So MPN, we are differentiating actually MPN in 3 different product groups. So here, when I start, maybe not from left, but from the right side, most of our customers initially want to have the isolated MPN. They want to have the security, they want to have complete isolated network, but there is a cost for that. So you need to implement, you need to have a special core dedicated just for that customer. So it is as well a cost and benefits behind it. But there are also different solutions like hybrid MPN we are calling. So you are still using a core network, but not all the functions of the core network are on the customer premises. And with that, you can still use the Vodafone services in the outside of the area of the world. And then you can, but inside the campus, you can have different services on top of it with, of course, much better experience. And when we come to the segregated MPN, it's kind of an MPN, but you don't have anything actually on the customer premises. Of course, with the SA core, you are be able to use the slicing option and give the slice to the customer so that you can isolate the customer traffic from the existing traffic, and then you can also give the segregated MPN solutions. There are, of course, pros and cons for each of solutions. You can provide low latency in each of the solutions depending on the use case. But I think the cost perspective and as well the security perspective, how much you want to isolate your customer services from the existing world will play a critical role here to decide which product to select. When we continue, so what we are doing as a partnership, we have a partner called Mext. Mext is a metal industry center, and they are, we have together with our partner, we have built the technology center of Mext in Ataşehir in Istanbul. And in this facility, we can show how much we can benefit from the 5G use cases. And this is actually showing how we can benefit from technology and connectivity point of view for the Industry 4.0. So here we have robots, we have the kitting stations, we have the digital twins. So it is showing how much automation inside the factory can help them. And they are having, daily many visitors from different industries. They are going there and they are seeing the real examples of the use cases. And then they are also thinking about if they need to do MPN in the future or not. And here we are actually working on enabling the digital transformation, working how to improve the low latency, flexible capacity and QoS, and we are working together with 4G and 5G. So we are showing what we can do with the 4G, and we are showing as well what we can do with the 5G. So these possibilities, these use cases are all available there. And when we ask for our customers what they actually want to see is more on the right-hand side. So when we go to the airport, for example, they are more interested in the surveillance systems and cameras and maybe drones, because the airport, they need to check from the height. And then push-to-talk, when it's, or video processing is one of the critical business cases. And on mining industry, we have, again, digital twins. So whatever you have as a facility, you can actually control with the digital twin. And then AGVs. So these are the critical use cases that are asked for us together to use with the MPN solutions. So I think 5G, even though we don't have it in Turkey, have already great opportunities initially with the enhanced mobile broadband, so the top corner on the triangle. But together with the SA core, we are seeing as well examples of the ultra-reliable low latency and massive type of communications. So at the moment, as far as I could get from the GSA report, so we have around 300 operators in the world in 114 countries who have enabled 5G in their countries. But when we check the SA core, which is critical for the other two use cases, and improved latency, we see that 121 is still working, and 41 or 43 is just enabled. So only 15% of the operators today, which has 5G already, have enabled the SA core. So it still takes time. So we believe that NS mobile broadband was the initial 5G, but with the additional use cases and verticals, and with standalone core, we are already moving to the 5.5G core, 5.5G. So 5.5G will continue. So this will be the continuous improvement and continuous development. So we will have new verticals. Of course, uplink will be more enhanced with the new capabilities, but I think it will be more driven with the new verticals, but the big step after initial 5G is already there. Thank you very much for your listening.
Thank you, Erhan. And now we come to another break. So please join us back here about 3 o'clock for the last part of the session today. Thank you.